Okay, sorry about that. My hair was. Um, in this video, I'm going to introduce you the concept of vectors. Let's see. So from now on, we're going to discuss force. Force is a push or a pull. It's something that's pushing an object or pulling an object. That is force. But you can see if you push the object into one direction or the other direction, it gives a different result. Not just how much you push, but also which way you push matter. So the quantity that matters not only the magnitude, how much in magnitude, but also the quantity that matters with the direction is called vector. And let me just use the notepad. Here. So again, the force is a push or pull. So if you have an object that you're pushing, into this way, or the same amount, you push it, gives a different results, even though let's say it's about the same magnitude that you're pushing. And we use force is a quantity that's called vector. It's a vector quantity. And we're going to talk about that. But for the force, we use a unit that's called Newton. So I could be pushing this box 2 Newton to the right, or same 2 Newton to the left. It's a different force. Same magnitude. In this case, it's the same magnitude of force, but it's a different force. Because of its direction, right? One of them, the box is being pulled 2 Newton this way, or 2 Newton this way. It makes a difference. So the Newton is the unit. It's the unit. It's almost like for the mass, you can use a gram, kilogram. Newton is a unit for the force. And the force is the quantity that's called vector, that it's not just only the magnitude, but also the direction matters. We call such a quantity vector. So you have a 2 Newton that's moving to the right, being pushed to the right, and 2 Newton being pushed to the left is a different force applied. It's not identical. So here I'm going to define the vector and what do you call that? Scalar. So here is a quantity that's called vector, and another quantity that's called scalar. Vector has the component that's magnitude and direction. So all the vector quantity has the magnitude and a direction, and a scalar quantity only comes with the magnitude. Let's see. So I say example vector is a force. Let's see. If somebody asks you, where is the bathroom located? you could say, okay, it's 2 meters or 1 block away. But do you think if I say just 2 meters from here or 1 block away from here, do you think the person can get to the bathroom? We can't. A person still have to ask more questions. 2 meter from here, which direction, right? 2 meter in that direction, 2 meter in that direction, 2 meter in this direction makes a different result. So you need to not just only say the magnitude, how much, right? But also which way. So the magnitude is the how much. This is magnitude means how much. In the direction is the which way. In the case of scalar, let's do this. In the case of scalar, we have a how much only. So I mentioned about somebody know about the bathroom. You need to not only say the magnitude, how much, 2 meters or 5 meters, 2 kilometers, but which direction? Which way is the fire happening right now? It's 3 miles north, southeast. Oh, my house has been okay because fire has been happening in the west, and I'm on 5 miles east from the fire. Fortunately. So that kind of a thing. You need to, so that is actually a direction or position. So position, to say where you are, is actually a vector. You need to have an origin, and then you say from here, 2 meters that way, 5 meters that way, that kind of a thing. So position is actually a vector. What else can be vector? Scalar, on the other hand, is only the type of quantity, physical quantity that's only express magnitude. So let's say temperature. Do you think the temperature has an information about direction? It says, okay, it's 80 degrees Celsius, right? When you hear 80 degrees Celsius, it's just 80 degrees Celsius. 80 degrees Celsius here, over there, it's the same 80 degrees Celsius. It has the value, so it's a positive. But in the case of a temperature, there's a negative 10 Celsius, let's say. But the negative, when it says negative, it's not that it's changing its direction. It's just the value is lower than 0. So even when you hear negative, it's not always, it means that it's a direction. Like a case of temperature is only expressing the magnitude. It has no information about direction. So therefore, temperature is a scalar quantity. What else is the scalar quantity? What do you think about volume? When we talk about volume, it has no directional information. 5 cubic meter is just a 5 cubic meter. Same as area. Length, like 1 meter ruler, length is actually a scalar, but position is a vector. So that is the length is a scalar quantity, position is a vector quantity, force is a vector quantity, temperature is a scalar quantity. So from now on, when we introduce you a new physical quantity, we have to be clear that is this a vector quantity or scalar quantity. And for vector quantity, like force, typically I use a symbol of the force, F, and then I write arrow on top to say that this is a vector. So F equals 10 Newton pointing towards north. Or to the right or up or down is the correct way to, it's a complete information about that force. And this arrow represents not just only the quantity, but oh, it's a vector quantity. It's not a scalar quantity. So to represent vector, we use arrow. Vector, to talk about vectors, we use, graphically, we use arrows. So when I say 1 Newton to the right, or 1 Newton, these two are different force, different vectors. They are different. And a different vectors. So what it means here is that length. So here, when you draw an arrow, the length, let me see, length represents the magnitude. So both of them here is 1 Newton. So the length should be the same. It's the same length, but let's see, arrowhead with arrowhead. Arrowhead represents the direction, which way the quantity is pointing to. So in the case of the one on the left here is pointing to the right. So it's 1 Newton to the right, and then another one is 1 Newton to up. So they're both different vectors, same magnitude, so same length of the arrow, but pointing to the north, up, or pointing to the right is a different vectors. But you can see that since if it's a magnitude, as long as the magnitude, which is the length of the arrow, and the direction, which is the arrowhead, as long as they're the same, that means it's the same vector. So you can, for vectors, to represent vectors graphically, you can, sorry, parallel shift. Which means that if I have a, let's say in this case, 3 Newton here, right? And then I have exact same length and pointing still in the same direction. As long as they have they maintain the same length, okay, about the same length. It should be the same, exact same length, and it's same direction. If it's a parallel shift, they're identical. Identical force. So you can move the vector which way, wherever, as long as you maintain in the same direction and magnitude, you can parallel shift this vector anywhere you like, arrow anywhere you like to represent that force. All right. So then sometimes you may have multiple operation, multiple vectors. When you have, let's say, when you add two temperature or two objects, let's say, that has the length of 5 meter, not the length, maybe the cubic meter. 2 cubic meter plus 1 cubic meter is 3 cubic meter. So if it's just a scalar, you can just add or mathematical operation. Let me see. For scalar, you can add or subtract like how you do. Like you have a 5 meter plus 2 meter equals 7 meter. It's just a length. This is just a length. But let's say that if you were to tell a person, you want to go 5 meter from here, but then you want that person to turn right 2 meter east. It's not, the answer is not a 7 meters. It's not that a person has walked 7 meters, right? So because in the case of vector, the direction matters. So then how do you add? In this case, the answer resultant is not 7 meter. Let's do a simpler one. If I have an object here, pushing this object 2 Newton to the right, and then if I push this object 2 Newton to the right, then this object overall will have 4 Newton to the right. But same thing, 2 Newton to the right, 2 Newton to the left. What is the resultant of this box now? If one case that you have a 2 Newton pushing to the right, 2 Newton pushing to the left, what's the resultant? That's right. In this case, it's 0 Newton. So it's the same 2 Newton, 2 Newton, but how you add them, the direction, when you take into account of direction, it matters. So then how to add? How to add vectors then? How to add forces, how to add those directional vectors and things. Here we use something that's called parallelogram. Okay. You're gonna draw parallelogram. So let's see, parallelogram. Adding vectors. So let's say I walk this much. So this is vector A. And if I walk this much, this is vector B. Where do I end up? You can also use the tip to tail method too. It's the same thing that you're doing. Or you can do the parallelogram, right? So then I can parallel shift this A vector anywhere I like. It won't change the property of this vector, right? As long as I keep the same length and the same arrowhead. So imagine that here, from the end of a B here in this case, I can make the exact same parallel to this A vector. Same thing here, I can make a exact parallel to the B vector at the end of the A. So this and this is exactly parallel. Then the resultant will be starting from the same location. So in this case, both A and B starts from the same location. Then the resultant will be like this. This is C is the resultant vector, which means C is equals to A plus B. And in this case, you can see B plus A is also the same thing. So when you have two vectors that's starting from the same location, let's say there is an object that's here, right? The box is here, that has the force applied into this direction, and then maybe another force that's applied into this direction. Then the resultant of the two forces is, adding these two, is going to be like this. This is going to be the resultant. This is going to be A and B. And this is going to be C, which is A plus B. Or you can use the tip to tail technique too. Sometimes you just when you talk about direction, you're starting from this location, right? This is where you met a person and then you want to find where the location of the restroom. So you walk 10 meters this way, 10 meters to the right, but then you walk this much, 7 meters in that direction. Your final location will be, so in this case, it's a tip to tail. So you move from here, but now notice that a starting point of the second vector is at the ending point of the first vector. So they don't share the same origin. Then you can use the tip to tail technique to say that final vector, the resultant, will be from counting from, okay, from where you are at, the restroom is located in this direction. So when you don't have the origin at the same, they don't share the same starting point, then you could use a tip to tail. To add those two vectors, right? So to add the two vectors, commonly for physics, because especially for forces, you talk about often you have a multiple forces that's applied, exerted on a one object. So then you need to find out what's the resultant of the force. So you have a gravitational force, friction force, maybe other forces exerted on a one object. Then you need to know which direction is a gravitational force, which direction is a friction force, how much. Therefore, you can find the resultant force, which is called net force, right? To find the net force, you need to use What do you need to use to find the net force? Parallelogram, because it's only starting from the same object. You add them, you draw two parallel lines, and then you can find the forces. What happens if you have not just only two forces, but three forces for three vectors? What happens? Let's say A, B, C. What happens when you have three vectors? You want to do probably the answer is D, which is A plus B plus C. And you can interchangeably change that. This is the same thing as if you want to do it A plus B first and then add C, or you can also do A plus B plus C. So you can find the B plus C first, then add the resultant vector of B plus C to A. And that's how you can find the D. So when you have three vectors to add, you can do this way. What happened for subtraction? So let's say in this case, I have so C equals A minus B. And I have A vector here, and then I have a B vector. And I want to find A minus B. I want to subtract it. How do I do? As long as it's the same magnitude, it's the same quantity, same length, it's the same magnitude, same quantity. But minus represents that it's in the opposite direction. So you can write minus B, it's in the same length, but point into the opposite direction. So now this is the minus B. That's starting from here. That's minus B. So exactly same magnitude, but point into the opposite direction, it's going to be minus B. And I hope you see the C, which is A plus minus B. So once you flip the B into a minus B, like this, right? Once you flip it, then you can add the A plus minus B. And that's the same thing as A minus B. Then we can just use the same rule as we've been doing. Make a parallelogram, right? This and this is parallel. This and this is parallel. Then the resultant will be starting from same point, merges onto the diagonal. This is going to be the C vector. This is the C vector. All right, so I hope you see idea of a vectors, and then for vector operation, you know how to add and subtract vectors. All right, I want you to be able to add and subtract vectors, because we're going to be doing so many of the multiple forces, multiple velocity. Now, velocity is not, but multiple forces for search for sure. So force is a vector, so you need to know how to add those forces. And you can't just say 2 Newton. So what is 2 Newton plus 2 Newton? Can you ever say what's 2 Newton plus 2 Newton? That's not a good enough information to answer. 2 newtons plus 2 newtons in which 2 newtons? Which direction in 2 newtons you're adding those 2 newtons? 2 newtons and 2 newtons can be this way. 2 newtons can be this way. 2 newtons can be this way. 2 Newton, 2 Newtons can be this way. It depends on which way they are relative to each other. It gives a different result. So you need each of the 2 Newton, we need to know the direction. So typically vectors, we use our arrow to represent the vector. The length represents the magnitude of the vector, and the arrowhead represents the direction. Then how to add those 2 Newtons and 2 Newtons? You use parallelogram. You draw those two vectors, then you draw the parallel lines of those two from the end of each vectors, right? End of each vectors, you draw parallel line where it intersects from the origin that they're sharing, same origin, to where it intersects. That's going to be the resultant. That 2 Newton plus 2 Newton. Okay, so here I can have an example again that this is 2 Newton, 2 Newton. What's this vector? What is the resultant of these two? This 2 Newton, 2 Newton. Again, this is A and B. What's the C, which is A plus B? What is it? It's same, take 2 Newton and 2 Newton. I could have a 2 Newton like pointing this way, another 2 Newton pointing in this way. What's this? What's this? Are they all going to have a 4 Newton? Or the case that's only the case that you have a 2 Newton, 2 Newton, right? This last case is going to be 4 Newton. But you don't know. So the C vector to find, I want you to find the C vector for all these cases, all the cases. And then when you draw C vector though, you can pretty much, so let's say you can say what I drew, you can measure the length, right? With the ruler, okay? And then, okay, I say 1 inch as a 2 Newton. Then if it's at 1.77 inch, then you convert that 2 Newton into 2 Newton times 1.7, then you can find out what's your resultant. And you can find the angle by measuring a protractor. And that's going to be your resultant vector. So you can say, okay, it's going to be 3.4 Newton pointing in 37 degrees from east, or positive x. So that's how you can precisely explain the direction and magnitude of the resultant vector, which is A plus B. Vector A plus vector B. So you can do this way, and we're going to do worksheet on the vectors. It's very important to do the worksheet on the vectors, so I hope you can do it smoothly after watching this video. Okay, so this is the end of the chapter 2 vectors video, and we're going to talk more about forces in the other video. I'll see you in the discussion.